Yeah, good evening. Good evening, everyone. Good evening. Shekhar, post in the groups. In all the groups, post. Yeah, can we start? Shekhar, can we start? Yeah, let's start now. Let's start. Let's start. Yeah, good evening, everyone. Good evening. So in the last class, we done approximately 10 problems. I think let's go there. All are very good problems we done. I think this also done in the last class. This also done in the last class. I think this is the place. Yeah, this is the first problem of today's class. This is the first problem of today's class. Can you go ahead? This is the first problem of today's class. Can you go ahead? Yeah, everyone try. This is the first problem of today's class. Can you go ahead? What is the answer for this? A graph is planar if and only if option A, it does not contain a subgraph homomorphic to K5 and K33. It does not contain a subgraph isomorphic to K5 and K33. Right? Remember, homomorphic, isomorphic. Right? In this problem, you have to see the difference between homomorphic, isomorphic. Yeah, go ahead. Everyone try. A graph is planar if and only if some options are given. Can you try what will be the answer for this? Let's see how many people will give answer for this. Everyone try. Everyone try. Yeah, I think so. Remember, it's not isomorphic, it is a homomorphic. Isomorphic means exactly same. Homomorphic is okay. So if I want to say some graph is, suppose in this graph I want to say planar. If I want to say this planar graph is, if I want to say this graph is planar, in this graph I don't want to see any subgraph which is homomorphic to K5 or K33. K5 or K33. Right? I don't want to see any subgraph which is K5 or K33. So some people are asking, suppose some people are, what is the subgraph, sir? Let us assume that it is a subgraph. Something is there outside, something, right? So it is a subgraph. This subgraph is K5. It is a K, right? K5 diagram. It is a K5 diagram. It is a K5 diagram. So remember, it is a K5 R, right? In the place of K5, this is the K5 or K33. This is the K33 diagram. This is the K33 diagram. Right? So K5 diagram, or this is the K33 diagram. K33 diagram. So remember, these are exactly, right? Means I don't want to say subgraph should be isomorphic to K5 or K33. It will be homomorphic. Some people are asking, sir, what is the homomorphic, right? So in this one, some subdivisions may be there. Maybe here one vertex C. So architecture, if you see the architecture, it look like a K5, but there may be so many vertices in between. See, more vertices may be there, more edges may be there, right? You can, subdivisions can be there, but appearance will be look like a K5. So that is the meaning of homomorphic, right? Homomorphic to K5 means K5 kind of behavior, but maybe more vertices are there, maybe more edges are there. K33 kind of behavior, maybe more vertices are there, maybe more edges are there. Subdivisions are allowed, right? Architecture is like K33, but subdivisions are allowed. Subdivisions are allowed, right? Now some people are asking, sir, end operator or operator? End operator saying that both not there, then only it is a planar. If one is, let's see this one, both not there, then only it is a planar. It is saying if one is there, it is okay, is saying. If one is there, right, according to option A, it does not contain subgraph, homomorphic to K5 and K33. Homomorphic to K5 and K33. Both not there, then only planar it is saying. So option D saying that you don't want to see either K5 or K33. So this one is the answer. So you want to say indirectly, only one is there, it's okay. He is saying that one is there, no problem. But our operator is saying that one also not allowed. One also not allowed. So try to understand. Try to take care carefully. It does not contain a subgraph homomorphic to K5 and K33. It does not contain a subgraph homomorphic to K5 or K33. So D is the correct answer. So option A saying that both not there, then no problem. If one is there, it's okay, he's saying. Option A saying that one is there, no problem. Two there, then only problem. Right? So careful. Here you want to say that one also not allowed. One also not allowed. It look a little difficult, so please try to understand. Yeah, if you don't have any doubt, I can move to the next one. So remember, homomorphic, isomorphic, different. Homomorphic, isomorphic difference is, isomorphic means exactly K5. Isomorphic means exactly K33. But when you say homomorphic, diagram is like K5, but inside if you go, vertices may be more. Inside if you go, edges may be more. Subdivisions are allowed. In the K5 diagram, subdivisions are allowed. Remember end operator, R operator. Remember end operator, R operator. End operator is saying that these two not there, then it is going to be a planar graph. Means two not there, then only this problem is eliminated. So one is there, no problem. Something like that is saying no. One is there, then also problem. K5 there, it is not a planar. K33 there. It is not planar. Both not there. Right? Both not there, then it is fine. Anyone not there, both not there, then only it is a planar, otherwise it is not a planar. Having fears are only 2 months are left. Still not done with even half of the syllabus. Okay, complete. The only way to solve that issue is complete fast. The only way to solve that issue is complete fast. Everyone having same issue. Yeah, can you go to this problem? Can you go for this? Let G be a simple undirected graph with the vertex set V1 to Vn. Let delta G denote the maximum degree of G, and let n is equal to 1, 2, and so on denote the set of all possible colors. Color the vertices of G using the following greedy strategy. For I is equal to 1 to n, color of Vi is equal to minimum of J belongs to n. No neighbor of Vi is colored with J. Which one of the following is true? Some options are given. Can you go ahead? Can you try a little bit? I will help you. Can you try a little bit? He is given one greedy algorithm to color the given graph. To color the given graph, he is given one greedy algorithm. Please read it properly and try to find out what is the correct answer for this problem. Let G be a simple undirected graph with vertex set V1 to Vn. Let delta G denote the maximum degree of G, and let n is equal to 1 to denote the set of all possible colors. Colors the vertices of G using the following greedy strategy. For I is equal to 1 to n. Color of Vi is equal to minimum of J belongs to n. No neighbor of Vi is colored with J. Which one of the following is true? Can you go ahead? Let me know if you can solve this problem or not. Check everyone. Everyone try. Everyone try. Yeah, so let's try answer for this. let's try answer for this. So n vertices are there. Okay, n vertices. Let's try answer for this. N vertices are there. So V1 is there, V2 is there, V3 is there. So many colors. V4 is, sorry, so many vertices. V5 there, V6 there, V7 there. Some vertices are there. Okay, that's fine. Next one. See the next one. And colors also there, 1, 2, 3, and so on. Right? Some colors. 1, 2, 3, and so on. Some colors. Denote the set of all possible colors. Color the vertices of G using the following greedy strategy. For I is equal to 1 to n, take the first vertex. For I is equal to 1 to n, right? I is equal to 1. Take the first vertex. Then answer is colors. You can assign any color, right? You can assign any minimum color, right? If at all neighbors don't have that. So I will go to the first vertex. I will go to the first vertex. First vertex is not colored. You can take any color, take the minimum color. So I will take C1. I will take C1 color. Now go to the another vertex. V2 you go. Right? V2 you go. So let us assume that these are the edges. Edges also required. If I want to give coloring, I need edges also. Now V2 color is what? V2 color is what? Remember, V2 color is what? V2 color is what? Understand. So neighbors don't have any color. You can give anything. So you can give C1 here. Neighbors don't have any color. You can give minimum color 1. Now go to here. What is the color of this person? Right? If neighbors don't have any color, you can give C1. Neighbors are having 1 means you have to give next minimum color C2. Next one. Can you go to here? Right? So what color you can give? If neighbors don't have anything, I will give C1. Right? Just verify neighbors having C1. Yes. One more neighbor having C2. No. So I can give C2. Next one, go here. So neighbors having C1. Yes. Neighbors having C2. So you can give C3. What is the color of this? Neighbors are having C1. So you can give C1. Next one, neighbors are having C1. Yes. Neighbors are having C2. No. So you can give C2. So that's what the greedy algorithm what is given. So by seeing that algorithm, I can easily say, right, using that algorithm, you can give colors. Using that algorithm, you can give colors. Properly, you can give colors. Absolutely, there is no problem. This procedure results in proper vertex coloring of the graph. Absolutely, there is no problem. So option 1 is true. If anyone having objection, let me know. This procedure results in proper vertex coloring of G. This procedure results in proper vertex coloring of G. Absolutely, there is no problem. Absolutely, there is no problem. This procedure results in a proper vertex coloring of G. Okay, fine. Next one. So next one, if you observe clearly, the number of colors used is at most delta G plus 1. Of course, you will always see neighbors. What neighbors are having? You will always, suppose if I want to give color here, you will always see what the neighbors are having. Suppose assume that neighbors are, right, is neighbors are 4. For every 4 is isn't that different, you will select the new color. Suppose neighbors are 4, let us assume that neighbors taken C1, C2, C3, C4, right? You will take C5. So the right is one. The number of colors used at most delta G plus 1, where delta is the maximum degree. In the problem he mentioned, delta G denote the maximum degree of any vertex in G. So maximum degree of any vertex in G is delta G. So the number of colors used at most delta G plus 1. At most, exactly. That is also same. That is also perfect. Next one. The number of colors used is at most delta G. No, sometimes supposition that it is a complete graph. Four people are adjacent. Assume 5 colors needed. So if you want, you can verify. See this one: V1, V2, V3, V4, V5. Just I'm taking complete graph. In the complete graph, everyone is adjacent to everyone. Everyone is adjacent to everyone. So I think if you see the colors here, I will give C1 here. I will go to, right, I will give the C1 here. I will go here. Adjacent is C1 already there, so I will give C2. So I will go here. Adjacent is C1 also there, C2 also there. I will give C3. I will go here. Adjacent is C1 there. Adjacent to C2 also there, C3 also there, C4 I will give. I have to give C5. So if you want, you can verify. Maximum degree is 4. I have to give 5 colors. Maximum degree is 4. I have to give 5 colors. Right? Using this algorithm, if the maximum degree is delta G, I need a delta G plus 1, right? At most, not delta G. So option C is wrong. Option C is wrong. Option C is wrong. Next one. The number of colors used is equal to the chromatic number of G. I cannot give guarantee. Because, right, there is no algorithm to find out exactly how many colors required. Chromatic number finding purpose, there is no algorithm. Sometimes you may get more. Chromatic number actually may be 3. If you follow this algorithm, you may get sometimes 4. So there is no algorithm. The number of colors used is equal to the chromatic number of G. I cannot give guarantee. Sometimes maybe you will get more. That is the reason there is no algorithm. If anyone say option 4 is correct, you are indirectly saying chromatic number finding is decidable problem, because there is a one algorithm, greedy algorithm available. Using this algorithm, if chromatic number is working, then, right, chromatic number problem is going to be a, right, graph coloring problem is going to be a decidable problem. It is undecidable, so there is no algorithm. You cannot say this greedy algorithm is giving chromatic number. Sometimes this algorithm may give bigger number. There is no algorithm. You have to do manual checking. Means brute force, means undecidable. Is it okay? Anyone having small doubt also, please let me know. Small doubt also, sir. Sir, this is not okay, sir. I am not okay. Sir, this is not okay, sir. You just let me know. I will clarify. Everyone try. Which one of the following statements are true? This procedure results in proper vertex coloring of G. Yes. The number of colors used is at most delta G plus 1. Yes. The number of colors used is at most delta G. No, I cannot give guarantee. Right? So sometimes, right, there may be a chance that adjacent is 4 people. I have to take 5 colors because it is a complete graph. Sometimes it is failing. So 3 is wrong. 4. The number of colors used in this particular algorithm is equal to the chromatic number of G. Means indirectly we are saying chromatic number finding is a decidable problem because there is a greedy algorithm. No guarantee. No guarantee. Yeah, those people who are watching, please let me know. Do you have any doubt? Do you have any doubt? Let me know. Anyone? Hello? Everyone. If you don't have problem, if you don't have doubt, say move to the next problem. If you don't have doubt, say move to the next problem. If you don't have doubt, please say move to the next problem. Everyone say move to the next problem. Little doubt also they ask. Little doubt also they ask. I came here to clarify your doubts. Little doubt also there, let me know. So in this problem, end operator is saying that both not there, then only problem. If one there, no problem. No, if one is there, then also it is not planar. This person saying that one is their problem, both also their problem. Yes, of course. Right? Be careful. After exam is over, don't cry. Ayyo, I selected end. R operator I could have selected. Ayyo, I selected isomorphic. I could have selected homomorphic. It's a very tricky question. Very nice way of framing the question. Nice way of framing the question. Both, right? See, remember, anyone there or both are there. It is not right. It is not a planar graph. See this one. In the given graph, K, right? Homomorphic to K5 not there. Homomorphic to K33 not there, and both are not there, which is nothing but R operator. R operator means what? Anyone there or both there. Both there also it don't work. Anyone there also it don't work. But this person saying both there only. But this person saying both there and anyone there. It is not a planar graph. So careful. This is, I think, very interesting one. You want to say if anyone say fourth option also true. In this problem, if anyone say fourth option also true, you are indirectly saying graph coloring, there is a greedy algorithm. Graph coloring, there is a greedy algorithm. No, there is no algorithm. Manual checking is the only way. Yes, perfect. Yeah, can you go to this problem? Go ahead. Everyone try this. Everyone try. S is a infinite set. S will be a infinite set, and S1 to Sn be sets such that S1 union, S2 union, S3 union, and so on, Sn is equal to S. S is a infinite set, right? Where S is came from S1, S2, S3 union. Then what is true from the following? So remember this person, see this one, this person became infinite from all these sets union. From all these sets union, this one became infinite set. At least one of the set is infinite. At least one of the set is infinite. Otherwise, how it is possible? At least one of the set is infinite. 5 people union became infinite means at least one of the person is infinite. All may be infinite. At least one may be infinite. Maybe 2 may be infinite. Maybe 3 may be infinite. At least one infinite is the better option. At least one infinite is the better option. I think see, it's a very simple problem. It's a very simple problem. Let's go to next. Yeah. Can you go ahead? What is the answer for this? Yeah, everyone try. Everyone try. Everyone. Try everyone. Try everyone. Don't sit idle. Let G be a connected planar graph with 10 vertices. If the number of edges on each face is 3, then the number of edges in G is. Try. Try. What is the answer for this? Everyone try. What is the answer for this? Yeah, let's try this. Let's try everyone. Everyone try here. Let G be a connected planar graph with, remember connected planar graph. Connected planar graph. There is one formula for connected planar graph. B plus R is equal to E plus 2. If connected planar graph, there is one formula, B plus R is equal to E plus 2. You take any planar graph which is connected and check. Where R is the number of regions or faces. Where R is equal to number of regions or faces. So connected planar graph, this formula. Suppose not connected. Suppose not connected. Suppose not connected. Not connected planar graph. Not connected planar graph. Suppose means I cannot say not connected also. Simply say planar graph. Connected is not there. Simply say planar graph. Planar graph. But he didn't mention connected or not. Connected or not, he didn't mention. So answer is B plus R is equal to B plus R is equal to E plus K plus 1, where K is the number of components. That's simply planar graph. B plus R is equal to E plus K plus 1. Right? It's a connected planar graph. B plus R is equal to E plus 2. So if you want, you can take one simple example and you can check. It's a connected. You can take one graph and you can verify. Yeah. In this graph, if you see, I think 8 vertices. In this graph, if you see 8 vertices, and if you see edges, so I think 3 plus 3, 6 plus 2, 8, 8 plus 3, 11. 11 plus 2, 13. So number of regions count. 1 region, 2 region, 3 region, 4 region, 5 and 6 and 7. So 8 plus 7. 8 plus 7, 7 plus 7, 14, 15. Right? So can you count properly? Number of regions, how many count? Is it planar graph? Edges, how many? 3 plus 3, 6, 6 plus 2, 8, 8 plus 3, 11. B plus R is equal to number of regions, how many count? 1, 2, 3, 4, 5, 6, 7. Am I right? Is it planar graph? Verify. Am I done anything wrong? Am I done anything wrong? Please verify. Yeah, it's a planar. So number of edges, how many? Yeah, I counted the number of edges wrong. So 3 plus 3, 6, 6 plus 2, 8, 8 plus 3, right? 8 plus 2 is 10, 8 plus 3 is 11, 11 plus 2 is 13. I think it is 13. 13 plus 2, 15. 7 plus 7, 14 plus 15. Yeah, exactly. So same formula. Now, can you see this also? Everyone know, just only for namesake I'm writing. Everyone know, only for namesake I'm writing. Can you see this one? 3 components. 3 components. Remember, it's not a forest. 3 components. right? Now you can verify. Now you can verify here. You can verify here. So in this problem, three components. Number of edges count 3 plus 4, 3 plus 5, 3 plus 5, 8, 8 plus 1, 9. So it's going to be 9 plus 3, 12 plus 1, 13. So V, if you see the V, 3 plus 4, 7, 7 plus 2, 9. Regions, if you observe, 1 here, 2 here, 3 here, outside is 4. 9 plus 4, 13. So this is also 13. So if anyone don't know this formula, so please try to understand. Someone is given one more formula, E value less than or equal to 3b minus 6. That is also one more formula. For every planar graph, that formula also will work. Right? E less than or equal to 3b minus 6. E less than or equal to 3b minus 6. That is also one more formula. So as of now, it is required. So I written here, connected planar graph. Use this formula. Next one, simply he didn't mention connected planar graph. He didn't mention, maybe connected, maybe disconnected. When you say disconnected, component concept will come. Component concept will come. Whenever he didn't mention, component concept will come. But remember, it will work for, right? This simply planar graph means it will work for connected also, disconnected also. Simply planar graph means, right? When you say planar graph, this will work for connected also, not connected also. Right? When you say connected, k value becomes 1. When you connected, number of components becomes 1. 1 plus 1 becomes 2. So what I mean to say is, this formula will be used for connected also, disconnected also. This will be used for only connected. This is only for connected. This is for all. Let me write now. Only for connected. Only for connected. This is for all planar graph. Only for connected planar graph. So if anyone don't know, please can you note down this? If anyone don't know, please can you note down this? If anyone don't know, please can you note down this? Yeah. Now according to the given problem, let me check. So according to the given problem, because of connected, V plus R is equal to E plus 2. It is the assume that first equation. Can you see the second equation? Can you see the second equation? If the number of edges on each face is 3, means you want to say every region degree 3. If the number of edges on each face is 3, means every region degree 3 is saying. There is one more formula also. Sum of degrees of regions. Sum of degrees of regions is going to be 2 into E. So every region degree 3. So what is the meaning? 3 plus 3 plus 3 plus 3 plus sum of regions. All the degrees you calculate. So I think 3 regions into number of regions is in that R. 3R is equal to 2E. That is a one more formula. Sum of degrees means 3 plus 3 plus 3 plus, like that R time 3R is equal to 2 into E. These are the two things what I got from the above problem. Above problem saying connected planar graph. First equation came. Next one, every region degree is 3. So sum of degrees means 3 plus 3 plus 3 plus 3 plus like R times is equal to 2 into E. Now can you help me? I think if you observe clearly problem, 10 vertices he already given. He already given 10 vertices. See this one from. Yeah, I think let me do little more work. So 3R is equal to 2E. 3R is equal to 2E. So R is equal to 2E by 3. So let us assume that it is a third equation maybe. From 1 and 3. From 1 and 3. V plus R is equal to E plus 2, where V is already 10. 10 plus, what is the R? R is going to be 2E by 3, right? This is R is 2E by 3 is equal to E plus 2. So which will goes to, I want E only. Let's bring all the E one side. 2E by 3 minus E is equal to right? So I think E will go that side, so -8. Check if I done anything wrong. 10 will go that side, E will come this side, right? So that's okay. 2E minus 3, which is going to be minus E by 3, is equal to -8. So I think 8E will go here. Minus E is equal to -24. E is equal to 24. Someone said answer is 24. You are perfect. Someone said answer is 24. You are perfect. You use whatever way you like. You no need to follow me also. You do whatever way you like. You do whatever way you like. From 1 and 3, simply substitute 3 in 1. Simply substitute 3 in 1. So V plus R is equal to E plus 2. Finally, you want E value. See, finally, one then the number of edges are. You want finally number of edges. Just using the available equations, calculate the E value. Sir, this graph is considered in the three-dimensional space. Whatever it is, Aditya, don't think more, Aditya. Just don't think more, Aditya. Simply, it's a planar graph. Don't think more. Simply planar graph. Planar graph means nowhere edge crossings are there. Nowhere edge crossings are there. Whatever you are saying may be true also. Don't think more. If really required, we'll think about it. Let G be a connected planar graph. Planar graph. Oh, edge crossings are not there. And connected. Oh, this formula will work out. Right? Connected. This formula will work out. Sir, some people are asking, sir, can I use second formula, sir? B plus R is equal to E plus K plus 1. Yes, you can use, right? Because we said connected, only one component. Sir, can I use second formula, sir? Yes, you can use. K place keep 1. K place keep 1. For all planars, so second one will work. Only for connected, first formula will work. Right? So V plus R is equal to E plus 2. Right? Next one, as he mentioned, every region degree is 3. Sum of degrees of regions is equal to 2 into E. From that second equation came. Sum of degrees of regions is equal to 2E. From that second equation came. From there, third one came. Right? 1 and 3, if you substitute, then you will get the E value 24. Every planar is a complete graph. That is not necessary, right? It is a planar. It need not be complete graph. Every planar need not be complete graph. It may be complete, may not be complete. What is the meaning of planar? Edge crossing not there. Planar means edge crossing not there. That is the only thing what we can say. Is it okay? Is it okay? Hello? Is it okay? See, it is also, see, every person degree 3. So it's a degree 3. It's a degree 3. It's a degree 3. It's a degree 3. Right? Planar doesn't mean that complete graph. Planar doesn't mean that a complete graph. Planar means no edge crossing. Planar means no edge crossing. That is the only thing what we can say. So this formula you can use whenever planar, nothing is mentioned. Connected and right, connected, not connected, nothing is mentioned. Use the second formula. Right, second formula used for connected also. If it is a connected, keep K value 1. Connected, keep K value 1. Suppose disconnected, whatever K value they will keep, you can use it. This one you can use every time. Every time you can use this. Every time you can use this. Every time you can use this. This is only for connected. This is every time you can use it. Okay, perfect. Perfect. Let's move to next. Yeah, can you try this problem also? Can you try for this problem also? Try everyone, try everyone, try everyone. Yeah, let's try. Let's try. You people may be tried. You people may be tried. So let's see this. Let's see everyone. Everyone see this. Everyone see this. This is a graph. Listen, this is a graph. Everyone observe. Here one vertex there. Here one vertex is there. Remaining all vertices here. See this one. Here one vertex there. Here one vertex there. Here all vertices. C there. D there. E there. F there. G there. H there. I also there. Assume. So totally, see this one. Totally 1, 2, 3. 3 components are there. And remember 3 components. Actually 3 components are there. After deleting one person, what will happen? After deleting one person, what happened? See this one. A as it is may be there. B as it is may be there. Now see this one. You deleted C. Assume that you deleted C. Assume C deleted. If you delete C, what happened is, right? C gone out. Now see this one. D will become one component. E will become one component. F will become one component. G will become one component. H will become one component. I will become one component. If you see all of them, n minus 1 components will be there. N minus 1 components will be there. This is the maximum. Maximum these many components. Maximum these many components. So if you delete one person, it may be star graph. It may be star graph. Right? Then all will become 1 1 1 1 1 1 1 1. N minus 1 components maximum. Some people are asking, sir, what is the minimum? Some people are asking what are the minimums. Then don't delete this. Delete this person. If you delete this person, C will be as it is, D will be as it is, E also as it is, F also as it is, G also as it is, H also as it is, I also as it is, right? This is as it is, B also as it is, and from here A you deleted. So this component gone. So it became two components. Previously three components, now became two component. It is the minimum. So to this problem, maximum components are n minus 1, minimum components are k minus 1. So initially k is equal to 3. 3 components are there. Now number of components are minimum is 2, k minus 1. So the answer for this problem is k minus 1 is minimum, n minus 1 is maximum. Is there anyone who is having doubt? K minus 1 is minimum, n minus 1 is maximum. Anyone having any doubt? Let me know. Anyone having any doubt, let me know. Yeah, Srishti, do you have doubt? This is the very tricky question. This is the very tricky question. This problem is very tricky question. Aditya said minimum k minus 1, maximum n minus 1. Exactly. This is the very tricky question. Let me know if anyone having any objection. Anyone having any objection, please let me know. Anyone? They will ask you like this only. Small mistakes people will do. Small mistakes people will do. Small mistakes people will do. They will ask you these only. Small mistakes people will do. Can we go further? Can I move to next? Aditya, can I move to next? If everyone say move to next. Nitin, can I move to next? Nitin, can I move to next? Everyone say. Sir, it already has k components, of course. See, it is having three components. If you delete one vertex, it didn't mention which vertex. Assume I deleted this vertex. So I may, because of it is a star graph, it will generate so many components. See, it is a star graph. If you delete the middle person, it will generate so many components. I think if you count n minus 1 components maximum, 3 components are there. Suppose you are not deleted this, you deleted this, then there may be chance of 2 components. So remember everyone, see this one. Remember everyone, minimum 2 components. See, Given problem is what? Given problem contain three components. Given problem contain three components. If you delete one vertex, it may become two components minimum. Maximum it will become n minus 1 components. Understand everyone. Three components are there. If you delete one vertex, minimum it will become two components. Maximum it will become n minus 1. Right? Interesting thing is in between also possible. We are giving only boundaries. Right? 3 also possible, 4 also possible, 5 also possible, and so on. But maximum is this. It don't cross it. Minimum is this. It don't cross it. Minimum 2 possible, maximum n minus 1 possible, in between also possible. Some people are thinking that, sir, 3 also possible. No? Of course, I am also saying same. Some students are asking, sir, it is a 3 possible. No? Given one is 3. 3 also possible. No? Of course, but 3 need not be minimum. Minimum is 2. Maximum is n minus 1. 3 also possible, 4 also possible, 5 also possible, but maximum n minus 1, minimum 2. Arey, Shikhar, you got. Shikhar, you got. Right, perfect, perfect. I think everyone got. Everyone got. Can you try this? Can you try this? Can you try this? Everyone try. Try everyone. Try everyone. Yeah, if you read this problem properly, a set with n elements, C is a collection of distinct subsets of A such that for any two subsets S1 and S2 in C, either S1 is subset of S2 or S2 is subset of S1. What is the maximum cardinality of C? Yeah, now see this. Now see this. Now see this. A contain n elements. A contain n elements. So let's try A contain, right? A contain 3 elements. Assume that A contain 3 elements. Or I can go for 4 also. A contain 4. A contain 4. So how many subsets possible? C is the collection of distinct subsets of A. right? I think actually power set of A contain 8, right? I think 2 power 4, 16 subsets are there. So 16 elements are there. I think pi there, only 1 there, only 2 there, right? Only 3 there, only 4 there, right? And so on, and so on. Lastly, 1, 2, 3, 4 there. That's okay. That is the power set of A. But what he's saying is C is also collection of distinct subsets of A such that for any two sets S1 and S2 in C, either S1 is subset of S2 or S2 is subset of S1. Remember everyone? C is also collection of sets of A, but the condition is if you take any two subsets in the C, you cannot keep all subsets. If you take any two subsets, S1, S2, either S1 is subset of S2, S2 is subset of S1. Let me check. I will take pi, one subset I will take. In the C, I will take one subset pi. One more I will take 1. One subset I will take pi. One more I will take 1 because pi is subset of 1, of course. You take any two people in the C, right? Either S1 is subset of S2 or S2 is subset of S1. Okay, fine. So if I take, what about 2? Can I take 2 or not? Let's check. Can anyone help me? Can anyone help me? Can I take 2 or not? C contain pi. C contain 1. What is the reason? Pi is subset of 1. Okay. But I cannot take 2. If I take 2, 1, right? If you take 2 people, 1 and 2, 1 is subset of 2 fail. 2 is subset of 1 also fail. You cannot take it. But you can take 1, 2, you can take. So because if you take the 1 and 1, 2, 1 is subset of 1, 2. I think you can take this also. I think you can take this also. You take any two people. Either first one is subset of second one or second one is subset of first one. If you want, you can check. See, C not contain all subsets. C be a collection of distinct subsets of A such that for any two subsets S1 and S2 in C, either S1 is subset of S2 or S2 is subset of S1. What is the maximum cardinality of S? What is the maximum cardinality of C? Means C can contain maximum how many people? 1, 2, 3, 4, 5. So if I take 4, it is taking 5. I think B is the answer. Any objection? So if anyone say, sir, I have objection, let me know. See, most of the things you can solve with the common sense. Knowing some basics, what is set, what is subsets, what is cardinality. By knowing few basics, most of the marks you will get by using common sense and having some basics and practice. In examination, 30 to 40 marks you will get like this only. Just applying basics. What is set? What is right? What is the first? What is the meaning of set first? Next one, what is subsets? What is the cardinality? And having common sense. You should have common sense also. Knowing many things, not having common sense. Common sense in the examination, they will try a lot. Especially gate examination, they will check common sense like anything. That is the reason I seen some people in my life, right? They don't prepare that much, but they have common sense. They will get the very nice rank. There are some people they will prepare day and night. Common sense not there. They don't get the minimum marks also. Remember everyone, if you don't have common sense in the gate examination, you are going to get very less marks. If you have common sense, more marks you will get. Please start applying common sense. Please start applying basics. Someone is saying R. Sir, is instead of R, end is there, then answer is. Means what is the meaning? S1 is subset of S2, and S2 is subset of S1. So at that time there is equal, right? At that time there should be equality. There should be equality. What is the indirectly what you are saying? Equal. At that time subset are equal. S1 subset are equal to S2 and S2 subset are equal to S1. I think there is no meaning. At the time there is no meaning. Boshan, you may not get anything. You don't get anything. Then at the time pi. Maybe answer is maybe pi at the time. As Srishti mentioned, maybe pi may be answer. At that time pi may be answer. Yeah, let's move next. Let's move next. Yeah, can you try what is the answer of this? Yeah, try everyone. Yeah, exactly. See, planar graph such that every face is bordered by exactly 3 edges. Every face is bordered by exactly 3 edges. If you observe clearly, see this. 3 edges. 3 edges. 3 edges. So 3 edges. 1, 2, 3. Every edge is bordered by 3 people. Okay. But one thing, whenever it is a triangle, as I mentioned yesterday, when I mentioned triangle, compulsory 3 colors required. Compulsory 3 colors required. When you say triangle, compulsory 3 colors required. Minimum 3 colors, because further diagram may take more also. Minimum 3. 3 possible, maybe 4 also possible depending upon graph, but 2 never be possible. Let G be a planar graph such that every face is bordered by exactly 3 edges. Which one of the following can never be the chromatic number of G? So 3 possible, right? Depending upon graph may increase further also. Minimum 3 confirm, because of we mentioned every region bordered by exactly 3 edges. So minimum 3 colors, it depending upon graph further what will be there, because I don't know how many vertices are there, I don't know how many edges are there, but one thing confirm, every region having triangle, Every region having triangle means minimum 3 colors required, because 3 plus something. Sometimes maybe 3, maybe 4, maybe 5. So 3, I think okay, 4 okay, but 2 never be possible. Minimum 3, minimum 3. I cannot say 3. I cannot say 3, minimum 3, because I don't know the graph. I don't know how many vertices are there. I don't know how many edges are there. I can say degree of every region is 3. Means every region to make colorful, minimum 3 colors required. 3 colors followed by further story, I don't know. 3 okay, maybe 4 may be possible. 2 never be possible. 2 never be possible. Right? It is a very simple problem. Let's go to next problem. Yeah, can you try this? Try everyone. Yeah, let's see the answer. Let's see the answer. Everyone see. Everyone see. Set S contain 10 people. Everyone observe. Set S contain 10 people. Everyone observe. The number of tuples of the form A comma B such that A and B are subsets of S and A subset are equal to B is. Right? So from this, listen, from this you have to make two subsets, A and B. Right? From this set, you have to make two subsets, A and B, where A is subset are equal to B. A is right, A is subset are equal to B. Now understand. Now understand. If you want to satisfy this criteria, A is subset are equal to B. If you want to satisfy this criteria, A is subset are equal to B, you have to satisfy this condition. What is the condition? See the condition. See the condition. So if you take any element, you take any element, take the first element, you take any element, that element may be there in both the groups. That element may be there in both the groups. That is the one possibility. Right? For all XO belongs to SO, you have one possibility, X belongs to A group also, X belongs to B group also. Then 1 is subset are equal to 1, perfect. One more possibility is, one more possibility. Listen, one more possibility is If you take the 2, you can keep in both the groups. If you don't want to keep in both the group, that is also no problem. That is one more choice. X not belongs to A also, X not belongs to B also. That is then also no problem. Keep in both the groups, don't keep in both the groups, then also no problem. And one more possibility is, in the first group don't keep, in the second group keep. So 3 don't keep here, 3 keep here, because B is a superset. B is the superset maybe. But keeping in the first group, not keeping in the second group, not possible. So third possibility is X not belongs to A, but X belongs to B. This is the possibility. For every element, you have 3 choices. Keep in both the groups, don't keep in both the groups, or keep only in the B group. Keep only in the B group, keep in both the group, or don't keep. This also having 3 choices. 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 Every one having 3 choices. So 3 into 3 into 3 into 3 into and so on. Right? 3 power 10. Answer is 3 power 10. Answer is 3 power 10. Calculate properly. Calculate properly. Answer is 3 power 10. Every element having 3 choices. Calculate whatever it is, calculate. 3 3 is 9. 3 3 is 9. So 3 square, 3 square, 3 square, 3 square, 3 square. Right? So 9, 9, 9, 9, 81, 81. 81 into 81 into 9. Calculate properly. Calculate properly. But A should be subset of B, na? So B is a superset, right? You take any element, either should be there in both the groups, not there in both the groups, or only be there. Only be there. If you want, you can check. Assume that all came B. Every element is came in the B group only. It is a B group. No element is came to A group. Okay. Pi is subset are equal to A is subset are equal to B. That is also okay. No problem. Next one, 1, 2, 3, 4, and so on, 10. Subset are equal to 1, 2, 3, 4, and so on, 10. This is also okay. This is also okay. And one more thing is, don't take at all. This is also okay. You have 3 choices. Every element having 3 choices. Don't keep in both the groups. Keep in both the groups, or keep only in the B group. Is it fine now? So Aryan is saying sigma NCI 2 power n minus I is equal to 1 plus 2 whole power n. अरे आर्यन यू ड्रंक अरे क्या बोलते हो यार तुम क्या बोलना यार अरे आर्यन आर्यन यू ड्रंक you seen Pushpa movie or what? Pushpa 2 you seen Pushpa 2 and you are behaving whatever way you want. You seen Pushpa 2 today and you are behaving whatever way you want. NCI into 2 power n minus I is equal to 1 plus 2 whole power n. So this is the case. I think Abhiras, if that possibility will leads to this kind of combination. See, is it right or not? Check. Verify everyone. Keep everything in the B only. Don't keep in the A. Is it satisfying? Is A is subset or equal to B or not? Yes. Don't keep in the A. Keep in the B. Don't keep in the A. Keep in the B. What is the issue? What is the problem? Yeah, I think Aryan saying is correct. You are correct only. So what is that? Can you elaborate? What you written? Why you written that? Can you elaborate? We didn't get. You may be correct in your opinion. You are correct, but we don't know exactly why you written that. What exactly it is? Let me know. Aryan, can you expand little bit? Can you show? Can you throw some light on our face? Remember this kind of problem, many variations are there. This kind of problem, many variations. Please try to understand. Please try to understand this kind of problem, many variations are there. So please handle this, right? One more problem I given, similar kind of problem. One more I given. Can you try this? Similar kind of problem. One more problem I given. Can you say this? Many variations are there. Many variations. Don't by heart. Don't by heart. Yeah, can you try this? Are Abhiraz, you got or not? Abhiraz Bhaiya, you got or not? Abhiraz Bhaiya, you got or not? Previous problem solution, you got or not? Or you are thinking about Rashmika? Are you thinking about Rashmika? Rashmika in Pushpa 2, are you thinking about her? Are think about question number 19, yeah. Are Abhiraz, think about question number 19. Who is Rashmika? Question number 19. Question number 19 is Rashmika. Question number 19 is Rashmika. Oh, you are thinking Pushpa 2 heroine. You are thinking Pushpa 2 heroine. Gate is Rashmika. Okay. Okay, fine. Good boy. Good boy. Ashish saying heroine ka naam Pushpa. Oh, Ashish Bhaiya, you are also there in my class. When I say some nonsense thing, all nonsense people will type. If I start talking nonsense thing, all nonsense people will respond. Just if I say some nonsense, all will take attendance. Let S be a set of ready. Let S be a set consisting of 10 elements. The number of tuples of the form A, B, C such that A, B, and C are subsets of S. Similar kind of problem. Can anyone try this? Similar kind of problem. Can anyone try this? Yeah, perfect. Ashish, just casually I said. Don't take serious. Don't take serious, Ashish. Casually I said. Yeah, good evening. Good evening. Let S be a set of consisting of 10 elements. The number of tuples of the form ABC such that A, B, C subsets of S and this condition. Now see this. Now see this. S is this 1, 2, 3, 4, and so on 9, 10. So you have to take from, listen, you have to take from S so 3 subsets. You have to take from S 3 subsets. A also, B also, C also. 3 subsets you have to take. But A is subset of B, B is subset of C. This is the condition. This is the condition. Now understand everyone. Now understand everyone. If you take any element, if that element is there, if that element is there in every group, if that element is there in every group, still condition satisfied. Check. A is one is subset or equal to one is subset or equal to 1. Means having in all three, no problem. Right? So for all X belongs to S, first possibility, X belongs to A, X belongs to B, X belongs to C. So no problem. And one more interesting thing is, if you take the next element 2, 2 not there in every set. 2 not there in every set, still no problem. If not there in every set, no problem. Then also you don't have problem. Then also you don't have problem. Then also you don't have problem. Right? Next one. Can you see the next one? If you take the 3, listen, if you take the 3, 3 may be there, here also, here also. 3 may be there, here, B also, C also. A don't have, no problem. Because A is a subset. I think no problem. So one more case is, X not belongs to A, but X belongs to B, X belongs to C. That is also okay. One more case is, if you take 4, 4 is there only in the last. 4 is there only in the last. X not belongs to A, X not belongs to B, but X belongs to C. X belongs to C. Exactly. 4 possibilities. 4 possibilities. 4 possibilities. I think answer is every time 4. Answer is every time 4. It is going to be 4 power 10. Answer is 4, 10 times. 4 power 10. Exactly. Someone is mentioned 10, 48, 576. Yeah, please verify. This may be the answer. Check properly. Similar kind of problem. So 2 problems I given. Yeah, I think Aryan written. We will select I elements in the set. Then that element will only pair with the 2 power n minus I elements. Okay. Okay, Aryan. Thanks. Thank you so much, Aryan. Thank you. Yeah, fine. Right. That is the answer for this. Perfect. Let's go to next. So these kind of problems may come, please take care. These kind of problems may come, please take care. Next problem. Question number 20. Can you go ahead? Question number 20. Can you go ahead? The maximum number of edges in a bipartite graph on 12 vertices is. Tuple means this is called tuple. This is called tuple. Simply indirectly possibilities. Indirectly possibilities. Tuples are nothing but possibilities. This is called tuple. How many ways you can arrange A? How many ways you can arrange B? How many ways you can arrange C? That is called tuple. Right now, can you concentrate this? The maximum number of edges in a bipartite graph on 12 vertices is. Can you go ahead this? Everyone try. So remember everyone, when you say bipartite, you have to divide it into two equal parts. These 12 people, you have to divide into two equal parts. These 12 people, you have to divide into two equal parts. So some people are asking, sir, how much equally I can divide? So I think one combination, definitely in every group, M group, N group. In every group, at least one person required. M group, N group, at least one person. So first possibility, 111. Second possibility, 210. Next possibility, 39. Next possibility, 48. Next possibility, 5, 7. Next possibility, 6 and 6. Next one is reverse. Reverse. What is the meaning? 7, 6. Sorry, 7, 5. It will continue. It will continue. It will continue. Lastly, 11, 1. It will come like this. But remember everyone, bipartite graph, maximum number of edges are, complete bipartite graph, maximum number of edges are Mn. Complete bipartite graph. Bipartite graph, maximum edges are Mn. Complete bipartite graph, edges are Mn. In complete bipartite graph, everything is Mn. In bipartite graph, maximum Mn, because in the bipartite graph, 0 edges also possible, 1 also possible, 2 also possible. If you want, you can check here. 1, 2, 3, 4, 5, 6. See, no edge may be there. This is also bipartite. One edge only there. This is also bipartite. Two edges only there. This is also bipartite. So every edge there, that is called complete bipartite. Complete bipartite graph contain Mn edges. Bipartite graph contain maximum Mn edges. Bipartite graph contain maximum Mn edges. If at all you divided the vertices like this, 6 into 6, 36 edges possible. If you divide like this, 5 sevens, 35 only. If you divide like this, 4 eights, 32 only. If you divide like this one, 9 threes, 27 only. If you divide like this one, 10 twos, 20 only. If you divide like this one, 11 ones, 11 only. Right? If you divide like this one, 35 only. So like that. So maximum is 36. So in this problem, the twist is how you divide. He didn't mention. He said that bipartite, but how you divide? He didn't mention. You divide whatever way you want, but I want more edges. I want more edges. I want more edges. Yes, exactly. Aditya said K6, 6. Right? Let me write now. Bipartite graph. Bipartite graph with partition. 6, 6. Maximum edge, minimum edges are. Minimum edges 0. But maximum edges Mn. Maximum edges Mn. 6 into 6. 36. Bipartite graph with partition 6, 6. So minimum edges are 0. Maximum is 6 into 6, 36. But the question is, why you divided like this? Remember, if you divide like this, you will get the maximum number of edges. When they say maximum, please divide equally. If you divide unequally, you don't get maximum. I want to suggest to you one important thing. Some point of time in your house also, with your bias or with your behan, you have to divide the properties. Some point of time in your house also, with your brothers and sisters, you have to divide properties or something. Please go equally. Please go equally. Don't go for unnecessary trouble. Please go equally. At the end of the day, whether you gain or your brother will gain more, no problem. At the end of the day, your brother only, your sister only. So please go equally. Then finally you are going to get right. See, maximum edges are 36. You will get the maximum benefit. Best partition, equal partition, please go. Right? So go equally. Then you will get the best thing. 6 into 6, right? 36. Someone is saying 720. What 720, madam? What is 720? The maximum number of edges in a bipartite graph with 12 vertices is. Remember, bipartite means you have to do partition. Bipartite means you have to do partition. How you partition? If you divide like one side, 11 one side, maximum you will get 11 edges only. 2 one side, 10 one side, 20 edges only you will get. If you divide equally, 36 edges you will get. So answer is 36. Answer is 36. Answer is 36. So please go for equal distribution. If you get less also okay. If you get less also okay, because at the end of the day, you are bhaiya, your sister and your brother. If they take more also, no problem. Go equally. If not possible, less coming, go, it's okay. It's okay, because your brother and your sister, don't fight with them. Maybe they need. Don't fight with them. Yeah, can we move further? Can we move further? Can we move further? The maximum number of edges in a bipartite graph on 12 vertices, right? So say, some people are asking, sir, similar problem. Suppose n vertices are given. How, sir? Similar n vertices, n vertex, bipartite graph, n vertex bipartite graph, maximum edges. Do partition n by 2, n by 2. Do partition n by 2, n by 2, which is going to be n by 2 whole square. Fine. N vertex bipartite graph, maximum edges is equal to n by 2 into n by 2. N by 2 whole square. Right? So careful. So you have to read class notes, Srishti, class notes and RIC. Class notes and RIC. Right? And one more thing. When classes are going on, we done approximately we done 10 tests we done. On the DMS, we done approximately 10 tests. So classes we done, followed by 10 tests we conducted, followed by 10 tests every week I done. Whenever that subject going on, every week we done the test. So 10 tests we done, followed by RIC we are doing. If you do that, it is done. Just read the class notes one time. If anyone not done, read class notes one time, followed by 10 tests we done, followed by RIC. Everything we are taken care. Everything, this entire year we done like this one. Subject going on, we done the weekly tests. Subject going on, we are done the weekly tests. So subject first, weekly test next one RIC. Right. I think we done today approximately 10 problems we done. Tomorrow I am promising you, right, 20 problems I will do tomorrow. Tomorrow I will do 20 problems. Right? Tomorrow I will do 20 problems. So the tomorrow topic is graph theory, mathematical logic. Tomorrow story is graph theory, mathematical logic. 20 problems we will do. Yeah, today also I think 10 only happened. Tomorrow guarantee 20 I will do. Graph theory and mathematical logic. Graph theory, mathematical logic, tomorrow 20 problems will do. Right? Fine. Thanks. Thanks everyone. Thank you so much. Thanks everyone. Thank you so much. Please go through all of them one time. Please go through all of them one time. All of them one time, please go through it. All are nice problems. All are nice problems. If you are okay with every problem, you are perfect. Trust me, you are perfect. These are very dangerous problems. If you go through all these problems, you are getting means you are really done nice work. Thank you. Thank you so much. Good night. Thank you.